I have been throwing around object-oriented programming terms like classes, properties, and instances throughout this first day of training. In this video, I will formally introduce you to these terms, and then you will learn how OOP applies to the MXML tags that you are already using. You will also learn how to create your own MXML custom components with custom class properties. A core concept behind object-oriented programming is that problems are easier to solve if you model your programming needs on the real world. In OOP, your code describes the classes of objects involved in a problem to be solved, and then allows those objects to interact as they would in the real world. In this video, I will introduce you to OOP terminology and discuss how classes, objects, properties, methods, and other OOP concepts are implemented in the Flex framework. OOP revolves around categories of objects called classes. A class is essentially a blueprint that can be used as a template for creating specified objects. A property describes a characteristic of the class. In programming terms, you would call this a variable that is assigned to the class. A method describes the behaviors or actions available to instances of the class. In programming terms, you would call this a function assigned to the class. In OOP terminology, properties and methods are also known as class members. This is a simple real-world example of a class that is a blueprint for a category named ball. Every time the class blueprint is used to create an instance, the new ball will have properties like shape, material, and color that define it. Every ball will also have access to methods that define the actions and behaviors of the ball. You can see that the ball class has methods that define the way a ball can be thrown, caught, or bounced. Note that the word ball itself is capitalized. By common convention, class names are capitalized while properties and methods use camel case. Every ball that is created is called an instance of the ball class. You may also hear the term object used interchangeably with the term instance. You can create one or more instances of a class, and each instance can have unique property values and can behave in ways defined in the methods. Here are three instances of the ball class. The first ball, which I have named ball1, is round and blue and made of rubber. The second ball, ball2, is oval, brown, and made of leather. The last ball, ball3, is round, orange, and also made of leather. In all cases, the three balls can be thrown, caught, or bounced, although with varying degrees of success. A class generally has relationships with other classes. In this video, I will focus on how classes can extend and inherit properties and methods from other classes. I will also explain how you can control inheritance between classes by defining access modifiers. This class diagram shows four related classes. The ball class is the parent class that generically defines balls. The racquetball, football, and basketball classes are subsets of the ball class that define categories of specialized balls. The racquetball class is a blueprint for creating one or more racquetballs which can be different colors and bounce at different speeds. The football class is a blueprint for creating American-style footballs which are oval and can be different colors and materials. Consider a pro NFL football made of leather and a football made of the Nerf material, which is commonly used in children's recreational balls to make them soft and spongy. Class inheritance enables one class to extend another class. In OOP terminology, the racquetball, football, and basketball classes are called the child or derived classes. Since they are all subsets of the ball class, they are said to extend the ball class or inherit from the ball class. The ball class itself is being extended or inherited from, and is often called the base, parent, or superclass. In ActionScript 3, a class may only extend one other class. Code that can be reused is commonly kept in the base class and then extended by other classes. In the diagram, you can see that the racquetball, football, and basketball classes extend the ball class to use its properties and methods. For example, the racquetball class has shape, material, and color properties that it inherits from the ball class. By default, this class specializes in round and rubber balls but does not define the color. It also has properties of its own, like speed and weight, that are not shared by the ball class. Likewise, while the racquetball class does inherit the throw, catch, and bounce methods, it has its own method called hit. When you create an instance of one of the child classes, it has access to both the properties and methods from the base class, as well as properties and methods defined within the child class itself. You can, however, prevent instances of a child class, from inheriting properties and methods by explicitly defining access modifiers on the class members. In ActionScript 3, the access modifiers are internal, private, protected, and public. I will discuss these modifiers in more detail later in this video, but for now note that, by default, all properties and methods are set to internal, which means that the child class instances do inherit the parent class's class members. Properties and methods that are set to protected and public are also inherited, while those set to private are not. Sometimes you will want to inherit methods of a base class, but then modify them in your child class for that class's specific needs. This is called overriding the base class methods. To override the behavior of a base class method, you create a new method within the child class with the same name. The new method must have the same name, the same access modifier, the same parameter list, the same parameter data types, the same return type, and it must be explicitly marked with the override attribute. Within the new function, you must also call the super method, which directs the child method to invoke the functionality of the superclass for use in this method. Note that the overriding method can do nearly everything the overridden method can do, plus you can add your own code to do more. You will learn more about these requirements in later videos. For now, focus on the concept that a child class can both inherit a method from a parent class and modify it for its specific needs. Back to my ball example. You can see that the bounce methods in the football and basketball classes inherit directly from the bounce method in the ball class. However, since an American-style football is oval and does not bounce easily, I can change the functionality of its bounce to be more similar to a spike, which occurs when a player hurls the ball at the ground, usually in frustration. A basketball bounces much more easily, but I could modify its bounce method to work with more specific rules that define a dribble. Let me quickly review some of the OOP terminology and concepts that you have learned in this video. The ball class contains information and behaviors known as properties and methods, which are inherited by the racquetball, football, and basketball classes. Therefore, the ball class is commonly referred to as the super, parent, or base class. The three classes that are derived from the ball class are known as child or derived classes and are said to extend or inherit from the parent class. By default, properties and methods from the parent class are inherited by the child class, but you can prevent inheritance by defining access modifiers, which I will discuss more in this video series. The child class can use the inherited methods as defined in the parent class, or it can override the inherited methods to create additional or replacement functionality. Lastly, remember that the goal of creating these classes is to use them as templates for creating objects or instances that can interact in your application. This image shows 3 instances of the racquetball class. Each racquetball instance has all the properties of the class and can use the methods defined in the class. In Flex development, we often refer to the MXML code we write as tags. We call the application MXML code the application tag. This makes the code more approachable in some ways, but in reality, the application tag is actually an instance of the application class. You can create instances of any ActionScript class by using them in your application. You can also extend a class by creating your own custom components, properties, and methods. In Flash Builder, I am opening Help, Flash Builder Help to open the Adobe Community Help window. I am searching for the Spark list component and selecting Local Help to do a quick search of the content that has been downloaded to my computer. I am also selecting the ActionScript 3.0 language and component reference. Note that the first time you use the Community Help tool, you may be asked to sync your local content with the latest available content, which may take some time. The ActionScript language reference material, by the way, is also known as ASDocs. I am clicking on the first link that is returned to access the documentation on the Spark list component. Once you learn how to use ASDocs, you will likely find that it is an invaluable tool for your development needs. If you remember that all MXML tags are actually classes, then you should now be familiar with at least some of the terminology used in ASDocs. The inheritance section tells you from which superclasses the list components derive. You can clearly see that classes can fall into a long chain of parent-child relationships. Here you can see some of the class properties defined in each list component instance. The links in the upper right of the page are quick links to sections of this page. I am clicking on the Methods link to locate all the methods available in this class. You can see that there are some methods listed in the Protected Methods section and a link to expand the list to also show the inherited methods. This was just a quick introduction to the ASDocs. I will show you more details about the different reference materials like styles and skin parts and effects as the video series progresses. Now that you are familiar with the idea that MXML tags are actually classes, let me show you how this is implemented in your Flex code. In this next section, I will create this Flex application that displays 2 employees. I will create some instances of MXML classes and create my own custom MXML class with custom properties to display the image and names for each employee. This is the starter file for the application I am about to build. It only contains the application tag set and the comments that identify where I should place my code based on the coding convention that I am following in this video series. I'm switching to design mode and looking in the Controls branch of the Components view to locate the label control. I am dragging an instance of the label control and placing it in the upper left corner of the design area. Remember that in OOP terms, the label display in the Components view is really just a representation of the label class. The label control that I placed in the design area is one instance of the class. I can modify the instance properties in the Flex Properties view. I am setting the value of the text property to employees, the font weight to bold, and the font size to 20. You can see that this is reflected in the design area. From the Components view, I am dragging an image control and dropping it into the design area below the employee's text. In the Properties view, I am clicking on the folder icon next to the source property to locate the images directory in this project. I am selecting abrillium.jpg and then clicking Open. I want to use another instance of the label control to display the employee's name, so I'm dragging and dropping another instance into Design View below the image control. In the Properties view, I am assigning this instance of the label control a property value of Andrew Brillium. You may recall that at the beginning of this video I said that OOP models the real world, where classes are categories that define elements and objects are specific instances of these classes that are created from the class blueprint to work with other objects. In this example, I have created two instances of the label class. I have to remember to click the Enter key for the value in the text property to be taken. The first one displays the word employees and the second the name of the employee. I have also created an instance of the image class that has a property that specifies the image to display. When I save the file and run the application, FlashBuilder builds and compiles the application, and you can see that the application appears as it does in design mode. In the last few steps, you watch me create this display that contains the employee's header and Andrew's name and picture. Since there's more than one employee in this company, I know that I want to reuse the display of the employee's image and name. I'm going to turn this display into my own custom MXML component named employeedisplay.mxml and then reuse it as many times as I like. Of course, it's not very useful for me to show the same image and name over and over again, so I will also show you how to create a custom class property for my new employee display class and pass in the appropriate values for the image and name so that each instance displays a unique person. You learned earlier that a child class that is based on a parent class is said to extend the parent class. The extended class benefits from all the properties and methods of the parent class, but can also add its own specific requirements. You also learned about the group class in a previous video, so you know that it is a container which holds other components for display. I'm going to use the group class as the base of my new custom component. By convention, many developers will store all of their custom component class files in a separate folder from the SRC folder, which contains the main application file. In these videos and in the related exercises, you will use a subfolder named Components. In FlashBuilder, I am right-clicking on the SRC folder in the Package Explorer and then selecting New Folder. In the New Folder dialog, I am naming the folder Components and then clicking Finish. You can now see the new folder inside of the SRC folder. Now I want to create the custom component MXML class file. I am right-clicking on the Components folder and then selecting New MXML Component. In the New MXML Component dialog, I am naming the new component Employee Display. The based on value is already set to the group container in the Spark package. I want the component to resize itself based on its content, so I will delete the hard-coded width and height values. When I click the Finish button, you can see the new MXML file displayed in the editor view. I'm switching back to source mode. Note that this file looks very similar to the default main application. The main difference, of course, is that the main application file uses an instance of the application class as the base of the application, while this custom component uses the group class as the base of this new class. I'm returning to the main application file to cut the image and label controls. I am pasting them in the employee display MXML custom component file. Now these elements are part of the custom component rather than part of the main application. I'm going to go ahead and clean up this file a little bit and the application file to place everything in the appropriate location based on the coding conventions for this course. You use custom components similarly to Flex Framework components. You can see here that the employee display component is typed in MXML with X and Y properties. The only difference is that it does not use the MX or Spark namespace. It references the component namespace, which is defined in the main application as pointing to the components.star package, or more literally, the components directory that I created earlier. Back in the main application, I want to replace the employee image and name that used to be in the main application with the new custom component. In addition to the Flex Framework classes, FlashBuilder also shows you context-sensitive help for your custom component classes. I am typing angle bracket and then starting to type the name of the employee display component. As I do that, you can see that FlashBuilder locates the component and recognizes that it is in the components folder. When I hit the return or enter key to accept this selection, FlashBuilder inserts the code as expected and also creates the namespace in the main application tag. I need to close my custom component tag instance, and then I'm switching to design mode, where you can see that the employee display instance is displayed in the design area. It's not properly positioned because I did not define any X or Y properties for the instance. I am moving it to the correct location. Notice though that the component outline is larger than the actual content. When I return to the employee display MXML file, you can see that it has X and Y values defined for the controls. I'm switching to design mode for the custom component and repositioning the elements. I'm using the arrow keys. I'm saving the file and returning to the main application file. You can see that the custom component is not quite positioned right, so I'm going to move it again. From the Components View's Custom branch, I am dragging another instance of the Employee Display Custom Component to the design area and lining it up with the first instance. When I switch back to source mode, you can see that the component instance now has an X and Y property, and there's a second instance. The first one uses a single tag syntax, while the second one uses a tag block syntax. When I save both files and run the application, you can see both instances of the custom component displayed. Now I need to update the custom component to display different information for two different employees. To create and use a class property in an MXML custom component, you must first create a script tag set in the MXML component file for your ActionScript code. You will also need to define the class property as a variable with an access modifier and, of course, use the property as appropriate to the task. Lastly, you must pass in a value for that property from the instantiation of the custom component. I will start this process in the MXML custom component file. You create class properties in ActionScript. So far in this series, you have used MXML code but not very much ActionScript code. Remember that the Flex framework contains both programming languages, where MXML is geared towards display elements and ActionScript is focused on application logic. Often you will place both MXML code and ActionScript code in the same file. When this happens, the ActionScript code is placed inside of a script tag block, which is part of the FX namespace. I am creating the script block towards the top of my MXML file. Notice that FlashBuilder automatically generates a CData block, which is an XML directive to treat the content inside the block as non-XML elements. Inside the script block, I am using the var keyword to declare that I'm creating a variable. Next, I'm giving the variable a name. I want to pass in the name of the image to use for the employee's image, so I'm naming the variable image file. Since it will be a string value, I am using post-colon syntax to data type the variable to a string. I end every line of ActionScript with a semicolon to denote that the command is over. Remember from our discussion earlier that all properties and methods of a class are, by default, inherited by their children unless explicitly prevented by the access modifier. The access modifier also defines how a property or method may be accessed by other class instances. By default, since I did not declare an access modifier for my variable, it will use the internal access modifier, which means it can be accessed only by instances of other classes that were created in the same package. You will learn about packages in a later video. For now, simply understand that this means the property can only be accessed by instances of other classes defined in the components directory. A private modifier declares that the property can only be accessed by code in the same class. A protected modifier declares that the property can only be accessed by code in the same class or any class which inherits from this class. Lastly, the public modifier defines that the property can be accessed by any other code. I want to be able to access this property from the main application, so I will set its access modifier to public. It is considered a best practice to always explicitly define the access modifier for all your class members. The image file variable will be used to accept the name of the image file for the employee. I also need a variable that will accept the name of the employee. I am creating another public variable named full name that is also data typed to a string. I want to use these values in the image and label controls respectively. Therefore, I am replacing the hard-coded values for the image and full name with binding directives. When I save the custom component file, remember that FlashBuilder will automatically attempt to compile the application to let me know if it encounters any issues. You can see that two warnings appear that state that the data binding will not detect the assignments to these variables. You will need to use the bindable metadata directive to bind an ActionScript variable to an MXML control. In the ActionScript block, I am adding the bindable metadata directive before each of the public variables. I am saving the file so that FlashBuilder recognizes my changes and recompiles the application to remove the warning messages. The last step is to pass the correct values from the main application to each of the custom component instances. I am returning to the main application file and locating the two instances of this component. In the first instance, I'm moving the properties to the next line and then adding the image file property. FlashBuilder, as you can see, can locate this custom property in the code hinting options. I am setting the value to abrillium.jpg, which is the name of the image file with Andrew's picture. I am also adding the full name property with a value of Andrew Brillium. To the second instance, I am adding an image file property with a value of acotter.jpg and a full name property with a value of Annette Cotter. Now, I just want to show you that in order to force the code assist tool to appear, you can hold down the control key and press the spacebar at the same time. When I save the file and run the application, you can now see two instances of the Employee Display custom component, each displaying a different employee. For your next step, work through the exercise titled Creating MXML Custom Components with ActionScript Properties.